In this video, we are going to see steam nozzle related problems. A dry saturated steam at 2.8 bar is expanded through a conversion nozzle to 1.7 bar. The exit area is 3 cm square. Estimate the exit velocity and the mass flow rate assuming one isentropic expansion and assuming supersaturated flow exceeds. So this is the first of all we should understand this is which type of nozzle, conversion nozzle or diversion nozzle or the combination of conversion and diversion nozzle. In this problem this is the conversion nozzle. So it having only two conditions, that is the inlet condition and exit condition. Here they are given first of all two pressure P1 and P2 pressures are given, so not a problem. The second thing we are find out the which condition of steam, that it means initial condition of steam we should know. So first of all they are given the initial condition, that is a dry saturated steam. So we know the condition of steam is, first of all condition of steam is what? Bed steam. Okay, then we should know what's a dry saturator means. uh, so in this problem they are given dry saturated steam. Dry saturation is nothing but here the S1, that is the entropy formula, S1 equal to SG1. So the SG1 value directly taken from steam table is proportion, that is we are seeing the pressure P1 equal to 2.8 bar pressure. We can find out the direct value from SG1. So we know the S1 value equal to S2 value. So the condition of steam maybe S1 is initial condition is dry steam means most probably S2, that is a exit condition, wet is a wet steam. So we have to, we can also find out from some conditions, that is S2 S1 and SG2. From this condition we have to find out the condition of steam, that is S2 is always greater than, less than or equal to, we have to find out. So S2 is less than SG2 means the condition of steam is wet steam. Here the exit condition is wet steam. So we can take the formula for the wet steam. Entropy of the wet steam equal to SF2 plus X2 SFG2. So we know the S1 equal to S2. So you from the steam table we can find out the SF value, SG value, SF2 value. From this equation we can find out the X2 value. So X2 value you can find out means we can find out the enthalpy at exit condition. Okay, H2. So H1 value directly taken from the steam table. H1 equal to Hg1 is related pressure is P1 pressure, that is 2.84 pressure equal the H1 value we can directly from Hg value, because the initial condition is dry saturated steam. Then second condition wet steam. Wet steam means we have the enthalpy formula, that is H2 equal to HF2 plus X2 HFG2. So we know the X2 value, that is dryness fraction at the exit condition, and HF and HFG value directly we can take from stream table. So now we can find out the H2 value equal to 2635 kilojoule per kilogram. Same that specific volume, we can find out the specific volume V2 equal to X2 into Vg2. This is the wet steam formula for specific volume. Then we know the X2 value, we know the Vg2 value from steam table. From that we can find out the V2 value equal to 1.001 meter cube per kilogram. Then we are going to find out the velocity at exit condition. Exit means V2 equal to square root of 2 into H1 minus H2. This is the formula for the find outing the exit velocity. So we know the value of H1 and H2 We have already find out the h1 and h2 value. Substitute this value in this equation. We get the v2 value equal to 417 meter per second. Then we can find out the mass value. Mass m equal to area into velocity divided by specific volume. We know the value of the area. They are given the initial they are given the we want to find out the value of first of all area, isn't it? Area value they are 3 value they are given. You can see these diagrams. The exit velocity, we are going to find out the exit uh, m equal to a v divided by small v. We know the exit area, that is a2 value 3 centimeter square. So we can find out 3 into 417 divided by 10 raised to 4 into 1.001. So m value is 0.125 kilojoule per second. Then this is the first conditions. They are asking the two conditions. In first condition isentropic expansion, second condition assuming super saturation flow at exit. So we are find outing the first condition, that is assuming isentropic expansion. Next we are going to find out the super saturation expansions to flow. So we know the condition PV raised to 1.3 equal to constant. Then first of all we find out the velocity at exit. We have formula is there, 2n divided by n minus 1 p1 v1 1 minus p2 by p1 the whole raised to n minus 1 by n the whole power 1 by 2, where we know the value of pressure and velocity and initial pressure, final pressure and n value. So substitute all the value in the equation. From this equation we can find out the v2 value equal to 413 meter per second. Then specific